Okay. So the title of this slide is actually the subtitle of the book. The book that Kevin mentioned is The Works of His Hands, and the subtitle is A Scientist's Journey from Atheism to Faith. The book really is sort of divided in two parts. One is about my own personal journey, how I went from, as Kevin said, from a very strong atheist to eventually becoming a devout Christian. But it also includes, the other part of the book includes a lot of scientific information about what got me started on that journey. And one way to sort of show that in a sort of a graphic form is shown here. I started out as an atheist due to my family, which had for 3 generations had been very strong atheists. They were also very left-wing. My parents had been members of the American Communist Party in the 30s, and part of that, part of the dogma of communism is a very strong form of atheism. So I didn't just not believe in God. I was absolutely positive that no God could exist, and that anything related to spirituality was nonsense. And I had a very strong materialistic view of the universe. My father was also a chemist, and he was committed to pure materialism, reductionism, etc. So that lasted most of my early years, including going through college. But what happened as I was studying some science in college, including some physics, and then I went into graduate school in biochemistry, where I got my PhD, I began learning things that were very disturbing to that materialistic worldview, and kind of shook it. So I had to sort of, I definitely had to give up my views that everything was easily explainable by science, and that materialism and the scientific method could answer all questions. And so I became what I didn't call myself this, but I became an agnostic. I really wasn't sure what was true. I didn't think about God. I was no longer sure that there could not be a God. I just had no idea what was going on in this universe of ours. I'm going to actually, during the rest of my talk, I am going to present a few slides that discuss some of the things that I was learning back then, including things like the Heisenberg uncertainty principle and things related to biology, the complexity of biology, fractals, and some other things that really got me wondering strongly about the possibility that there may in fact be some kind of a designer out there, or something beyond just what we know from science. And then finally, I came to faith through a number of things, which I'm not going to talk about today unless there are questions. I'll be happy to answer. I will say that I did an interview with Cameron Bertuzzi of Capturing Christianity back in last summer. That video interview has been put on YouTube a couple of months ago and has received an astounding number of views, over 500,000. So I guess it was very well produced. But anyway, the reason I mention it is because I do discuss some of this aspect of coming to faith in that video, and that would be a good place to start, in addition to, of course, the book, which has details on everything. So I'm not going to, as I said, I'm not going to talk about that in detail today, but I do want to start talking about the whole question of science, faith, atheism, and start out with talking about, and this idea of scientific pointers to God was something I first read about in a book by Francis Collins, which I recommend strongly, The Language of God. That was a very important book to me because I actually read it after I became a Christian, but I was thrilled to find out that there was at least one other scientist who was a Christian, because at that point I didn't know any. And he talks about scientific pointers to God, and these are the ones that I think of. And a pointer is not a proof. It may or may not be evidence, depending on one's definition, but it's something that you can't ignore if you're looking at reality in today's universe. And one of the things is, of course, that there is something instead of nothing. And why would that be? Of course, that sort of points to the idea of God as creator. A very strong pointer is that, and you've probably heard this many times from people like you and other Christians who are also astrophysicists, and that is that the universe has some constants which are perfectly tuned to allow for galaxies and planets, stars, and of course us, life. The universe follows some amazing, elegant mathematical rules, and there's no reason why that should be true. Wigner has this famous saying that he is a physicist, or was a physicist, that there's this unreasonable ability of mathematics to explain the universe, to explain natural law. Human morality is, of course, a huge subject. I'm not going to get into it, but I believe that human morality, the fact that all humans know that there is a right and a wrong. They may disagree as to what is right and what is wrong, what is good and what is evil, but there isn't a human who doesn't recognize the existence of good and evil. And finally, I was learning things, for example, in quantum physics, which I had to learn as a chemistry major in college, that just don't make, quote, sense or common sense in the way we used to think of it. And they certainly don't point to a strict form of materialism. It doesn't mean that that these things from quantum theory are not true. They're definitely true. In fact, everything we're doing right now depends on it. But it's not the kind of reductionist materialism that we were used to before quantum mechanics and relativity hit the scene. And I'm pretty old. I don't remember when that happened, but I've read about it. And, it really changed our concepts of physics and science. And finally, of course, I'm a biologist or a biochemist, and within biology, there are many gaps in understanding, which could be, not necessarily are, but could be scientific pointers to God. And that includes the origin of life, about which we know very little, the origin of information, which is had happened at the same time as the origin of life. Consciousness, what is it? And where did it come from? These things are unknown. But one thing we have to be careful is not to go along with this idea of the God of the gaps. Just because there's a gap in knowledge does not mean that, as atheists like to say, God did it. We have to be a little careful when we go into that. And in fact, what I would propose is that there are actually two kinds of gaps. What I call an epistemic gap is a lack of understanding about nature because we just don't know enough. And that can be, and that's the kind of gap that can and will be and has been addressed many times and answered by some future scientific investigation. So that's, if you find an epistemic gap, it's just something that we don't know yet, but probably will be able to know. That is risky to call that a pointer to God, because you don't know whether that will remain a gap or be covered. On the other hand, there are other areas of knowledge, which I call ontological unknowns. And that is an actual knowledge, something we know, that is part of the natural universe that can never be fully understood by humans, and not by scientific investigation and not by any other scientific materialistic naturalism. So what are some of those? Well, I mentioned the Heisenberg uncertainty principle, and I'm going to show it in a second. But the Heisenberg uncertainty principle is a fact, and it's a fact of uncertainty. There are some things, what Heisenberg says is there are some things we can never know. And it's not a question of we need more research or we need new tools. No, this is a truth that is not changeable. So there is at least some cases where we cannot know some things. The other thing that I found very interesting and I've done some work on is the whole question of fractals and chaos, which basically talk about complexity at all scales, huge amounts of complexity, which make predictions and understanding of details very, very difficult. Now, chaos is deterministic, but it is extremely difficult to understand some very complex systems in a full sense because of the extreme complexity of how those systems work. There's also Gödel and his theorems of non-consistency in mathematical theories. And I'm not going to go into that because for two reasons. First, it takes a long time. And second, I am far from a mathematician, and that is, and these things are way beyond me. But I do understand the general idea of it. And it's similar to the Heisenberg uncertainty principle. A recent finding that has been talked about by Roger Penrose, who is a very famous British physicist, not a theist, is that based on Gödel's theorems and some other things, he has come to the conclusion that consciousness is non-computational, which is very interesting. And again, I'm not going to talk about that in detail, but it's something worth exploring. So Heisenberg uncertainty principle, and it's shown by a very simple equation here, says that we can never know the position and the momentum or the speed of an electron at the same time. We can know one of them, but we can't know the other. And the reason is what Heisenberg found is that the product of the two is greater than a constant. So if you know one, it's not equal to that constant. If it were, it would be easy to solve for one of them if you knew the other. It's greater than that constant, so it can be anything. And as I said, this is the basis of radioactivity. It's the basis of a lot of things in, for example, the way cell phones work. So this is an absolute truth. And as I said, this is telling us that no matter what we try to do, we will never get that knowledge. I'll say a few words about fractals and chaos. They're somewhat related. And what it is that most objects and processes in the real world, okay, not ideal things, not mathematical things, but actual trees and clouds and all sorts of things cannot be really accurately described or predicted because their structural and functional details maintain a constant level of complexity at all or many, depending on what it is, levels. So for example, if you had an airplane and you started taking it apart, as you started taking all the components of the airplane apart, each component would be simpler than the whole thing. And so if you take apart, the engine, that's simple. The engine is simpler than the whole plane. If you start taking apart the engine, all the components of the engine would be simpler. You can do this with a car too. It's probably easier than with an airplane. But anyway, and that's what we expect. But that is not the case for many, many natural structures. For example, leaves, if you start looking at them, they have a certain structure. If you start looking at them in more detail, the complexity of those details is the same as the complexity of the whole thing. This was first shown with coastlines, for example. And if you look at a coastline from far away, say from an airplane, it looks very rugged. But as you get closer and closer, it continues to look as rugged as it did originally. It doesn't get simpler as you get to smaller and smaller scales. And this is also true of certain, it's true in a different sense, but of certain processes. And I have here heartbeats in the stock market and weather. In fact, chaos was first discovered with weather. And that is that these systems work in ways that are so dependent on so many factors, especially initial conditions, that it's very hard to repeat exactly or predict exactly what's going to happen. And so when we complain about weather forecasting not being accurate, it will never get any better. It might get a little bit better, but you will never be able to forecast weather far into the future, because it is a complex and, in fact, can be a chaotic system. And that's why none of us are rich in the stock market, for the same reason. It's not predictable. This is actually comes from the original finding by Lawrence on the problem with weather. The constants here on the left, alpha, rho, and beta, are very, very finely tuned to give a particular curve. If you change one of these constants by a tiny amount, as you proceed to look at some measurement of the weather here, I don't know what this is, but it begins to diverge, and pretty soon, because of the change in that initial constant, the two curves are nothing like each other. They diverge completely. So if you don't know the values of these constants precisely, and that means to several orders of magnitude, it's impossible to predict the future of these curves. And as I said, this is true for heartbeats, for the stock market, for many, many other complex, chaotic systems. So there's a big difference between physicists and biologists. I don't know if there are physicists here, but if so, you might want to comment on this later. Physicists acknowledge the fact that there are ontological unknowns. They understand quantum mechanics, the uncertainty principle. They also know about epistemic gaps. There are things like dark energy, which are not understood at all right now, but physicists are hoping that they will eventually be. And of course, the famous elusive theory of everything. I'm not going to go into detail on that, but the idea is that there must be a theory of everything that will explain, or at least be consistent with, both quantum theory, relativity, and classical physics, but that has not yet been found. However, we would call that an epistemic gap, because some genius may eventually come up with something that will do that. One candidate is string theory, although my impression is that that is not universally accepted as a theory of everything. But that's very different from biologists, because biologists do not generally acknowledge the existence of ontological unknowns. They have a theory, the theory of evolution, by they I should say we, which will, and the idea is that the theory of evolution will explain all epistemic gaps, and there are no ontological unknowns. Now, this is not, I should make it clear, this is not part of biology. You won't learn this if you take a course in biology. This is a philosophical view that is currently predominant in the world of biologists. Many disagree with this, and we all know some of them. Buzzrana is one, I'm one, and there are several other well-known biologists, not all of them theists, who disagree with this. But it is very much the standard view in academic and research biologists. And what's related to that is this slide, which is about atheism among scientists. There was a survey of the Fellows of the Royal Society, and it turned out that physical scientists, physicists and chemists, are 3 times more likely to believe in God than biologists. And in fact, the percentage of atheists for biologists is 89%, which is pretty high, as opposed to 68% of physicists, chemists, and mathematicians. And physicists, I think, are among the lowest of that group. So I think there's some connection between this prevalence of atheism in the biological community and the idea that there are no actual gaps of reality in biology, and that the theory of evolution explains everything we need to know. Now, this is a famous quote from Richard Dawkins, which I think most people know of. I will I have a reason for showing it now, which you'll see in a minute. And that quote says, "The universe that we observe has precisely the properties we should expect if there is, at bottom, no design, no purpose, no evil, and no good, nothing but blind, pitiless indifference." And the reason I show it is because of those two words, no design, which is a very strange statement, because Daniel Dennett, another very famous atheist, has said the biosphere is saturated with design. And we can see that if we simply look at life. We're looking at flowers, animals, fish, birds, and of course, humans. And design is everywhere. And this is acknowledged by also by Richard Dawkins himself, who said there's no design, but what he meant there is that there's no design by a designer, because the source of design in biology, according to Richard Dawkins and Dennett and all atheists, is that it is the result of natural selection. It's the result of evolution. It has no purpose other than survival and reproduction. And evolution explains all the design, the apparent design, as it's usually called, that we see in life. An alternative view is that there is an intelligent agent who was a designer, and that the life's complex designs were designed by this agent and could not have resulted from blind random chance. A similar view is that, yes, there is an agent, but it's God, a divine being. And I actually hold to this view, that life's designs require far more than mere intelligence, which is why I'm not particularly fond of the phrase intelligent design. They're indicative of a divine agent, God, who used evolution as one of his tools for creation. Now, I mentioned this idea about biology, that they already have a theory of evolution. And according to biologists, Darwin's theory of evolution, as modified later in many ways, but the current theory of evolution is equal to or equivalent to the biological theory of everything. So in other words, evolution explains everything in life, and that's it. There's nothing that we need to worry about in terms of finding any more ways of thinking about it. And that's a very strange statement to make, because there's a lot of things about life that really don't fit into the theory of evolution. However, you're not going to hear that from a large number of academic biologists, and even several new fields of science and biology, which try to fit aspects of human nature, which of course is biology, into an evolutionary paradigm. And I think that those attempts are very mistaken and incorrect. And I think they're based on a religious rationale, and in this case, religious meaning atheistic religion. And what are those things? Well, behavioral genetics. Now, behavioral genetics is a real field. A good deal of human behavior has a genetic component, but not all of it. Evolutionary psychology is a field that also tries to explain all of human behavior, all of human actions through an evolutionary story. In other words, some of it is probably perfectly reasonable. Mothers have maternal instincts, which they acquired from evolutionary past. And of course, it's good for the species if mothers take care of babies, etc. But some of these ideas in evolutionary psychology are bizarre, and they're based only on theories. The whole existence of altruism and morality is explained by evolutionary mechanisms, that kin selection got out of control. And Richard Dawkins has said things like, well, when humans were developing. There were very few of them, so everybody they met would be a relative, so kin selection went to everybody. Okay, I mean, you can make an argument. This is not what we call science, however. This is what we call, thinking about something and coming up with what seems like a logical answer. There's very little science behind any of this. Genetic determinism is the idea that we are our genes, and genes determine everything about us. That idea is almost dead, I would say, and it's been killed by lots of scientific research. I think very few people still believe this, although some do. So the question that we need to ask is, there seems to be this connection between evolution and atheists. They love evolution, but so do I, and I'm not an atheist. And so the question is evolution really atheistic? It's not. There's nothing atheistic about it. When it was first proposed, Asa Gray, who was a close colleague of Darwin, and Wallace himself, who was the co-discoverer of evolution, were both devout Christians. And there were many others as well. And the point is that evolution is a biological scientific theory. It doesn't deal with anything that's metaphysical, spiritual, or moral, all of which are important issues in human life. Evolution only deals with the diversity of life, but it cannot contribute anything to the origin of life. And I'm going to talk about this in a little bit more detail. And this idea has been stated by both Darwin and Richard Dawkins. And evolution can explain, I believe, very little human characteristics, including consciousness, creativity, genius, music, art, or science. One thing that evolution, when we talk about evolution, we're talking about biological evolution, which is based on genes. And for humans, that's long over. Ever since 20, 30, or maybe 50,000 years ago, humans have changed, but by cultural evolution, from hunter-gatherers to agriculture to the Industrial Revolution. All of these changes are part of cultural evolution. And that is not based on genes like evolutionary theory, but it's based on human consciousness and the human brain. And this slide by itself could be a whole talk, but I'll have to stop there. In fact, there's something about evolution that most people don't think about, and it's very important when we talk about the origin of life. When you ask somebody, what is evolution? They'll say, well, it's genetic variation, which is translated into phenotypic variation. In other words, the genes, people have different alleles, different kinds of genes, and that gives different characteristics, different phenotypes. And that's followed by natural selection, because the different phenotypes have a different degree of fitness to the environment. So those individuals in a population who are more fit because of their genetic variation will survive. And most people stop there, but that's not the end. You can't have evolution if all you have is genetic variation and natural selection. You have to have something else. And that is an accurate inheritance of the phenotype to future generations. Okay, that's because evolution occurs in a population, and it requires that if a particular individual in that population has a mutation that confers an advantage, that means nothing unless that positive, that beneficial mutation is inherited by the offspring. And then it can begin to grow through many generations through the population. But the inheritance must be accurate in order for that to happen. And that's not a trivial thing at all, because accurate self-replication is a property of life and only of life. Nothing else replicates itself with any degree of accuracy. Now, I'll let that sit there for a second, because you're probably now thinking, yeah, but what about? And the answer is no. DNA doesn't replicate itself. No molecule, no chemical replicates itself. They all need enzymes to help. Factories don't replicate themselves. And in fact, houses don't replicate themselves. You might want, if you see a house you like, you might be able to make another one just like it, although it would be pretty difficult because I'm including everything, plumbing, electrical, every part of it. In fact, I would even include the contents. You want to have an exact duplicate, you have to get all the same pictures, books, furniture. And if you think about it, a house is pretty complicated. Everything in the house, all the components, all the things that make it work. But it's millions of times simpler than a single cell. And a cell replicates itself with 99.9999% accuracy. I mean, everything in the cell. And it's the only thing in the world, in the universe, that we know of that does that. And how does it do it? Well, we'll get to that in a second. But here, there's a certain problem here. You've got to have accurate self-replication if you want to have evolution. Because that was what I showed 2 slides ago, where I said that you've got to be able to replicate the cell, every part of the cell. But if you need accurate self-replication for evolution, evolution cannot explain why we have accurate self-replication in cells. Something else is going on, and we don't know what. So where do we go from here? I would say we have to do several things. One is to establish the fact, the reality, that there are indeed ontological gaps in biological understanding. I think that's very important. And I think one way to do that is to find new laws of biology that might not easily fit into the standard model of evolution. In fact, they probably won't. And we already have some of those, and there are many examples like convergence, which I can't get into, but there's also something called the extended evolutionary theory, the extended evolutionary synthesis, which is coming up with new ideas of how evolution works. And I'm absolutely convinced that when we are able to find these laws and theories that will explain things like the origin of life, or at least come close to that, I think that those theories and those new concepts will, as happened with physics, provide pointers to the design and creation of life. And those pointers, I believe, will lead to God. So I would like to take that credo that I showed before and modify it. First, to say that the design of life comes from a designer, a coder, and a reasoner. And to take that quote and redo it, the universe that we observe has precisely the properties, including life, that we should expect if there is at bottom a grand design, a purpose, such as the existence of life that can worship its creator, good and evil, and all that is needed to justify belief in the presence of God. And I think that that is a more accurate way to look at the universe.